Hello everyone, welcome back to this lecture. I hope all are well. In previous lecture, I discussed about what is outlier and how to handle them. And I also discussed about how to transforming the data. So let's recap in a few minutes. So outlier are those values. We are just understanding this outlier, missing value, transforming data because our raw data having a bad qualities. If I list down, first one is a inconsistent data and missing values and having a noisy data, having outliers. So these are the bad quality that make the raw data that is unsuitable for the to feed into the machine learning model. If you feed, it will model or algorithm will fail to understand the or learn the pattern which are present in the data set. Finally, it will lead to a lower performance of a model, or that is not required. So, to improving the performance of a model, to speed up the training and reducing the computational resources and memory usage, so we try to handling and making the data set, raw data set into a format that machine learning accept and speed up the training, where convergence or global minima will reach where loss is equal to or close to zero. That's why we are devoting a lot of lecture to explain the how we can do data pre-processing and data and feature engineering. In the data pre-processing, I discuss the missing values, inconsistent data, and outliers, and step by step I am discussing how to handle them. In the previous lecture, I discussed outliers are those value which is away from the rest of the data points. So how to handle them? So I discussed the Z score method, which if your value fall, if Z score for a data point fall within the range, so you can say your data point is not a outlier. If it is lie outside this range, so it means your data point is a outlier. So I will go in speed. If you have not watched my previous lecture, please watch it. This is a very important lecture. It will help you to build your foundation for a machine learning. And interquartile range method, in which we are taking a first quartile, third quartile, and taking difference, and we get range. If data point lies within that range, so it is not an outlier. If it is outside this range, it is an outlier. And instead of removing the outliers, we are trying to putting some values, having some methodology like replacing the top 5% of highest value with the next highest non-outlier values. And we discussed about data transformation, which is crucial part. Uh, we are trying to handling the outliers rather than to removing them. So we take a logarithm to make the difference between the data point become a close to the equal. And standardization, we are trying to find out the values that will having a mean 0 and standard deviation 1. It will help you to speed up your training of a machine learning model. Then I discuss min max scaling, where we are trying to scaling the feature value from 0 to 1, because we have different features in real data set. So we need to scale the value because our raw data set having a different scale for each feature. So we need to convert the each feature, having a scale range from 0 to 1. So in this lecture, I will discuss about if you have a data set, you have a numerical feature, and you have a categorical data as well. have a categorical feature like gender. You will have a male, female, female, male. So that is a categorical data. If you feed this data set into a machine learning model, but as we know, a computer does not understand the string. They understand only the number. So we need to convert the categorical data into the numerical representation. So in this lecture, I will discuss there are four methods we handling the categorical data or transforming the data into a numerical format. So let's begin this lecture. First, understand. Let me take a pen. Okay. Categorical feature represent distinct groups or labels such as color, red, blue, and clothing. If I talk about product categories, clothing, electronics, food, and many items. If I talk about gender, so we have male, female, and transgender or other. Okay. So we have a this is a three category we have. If I talk about gender, so category having distinct group or label. These are present in the features. Like if I say loan approved or not, so we have a yes no. If any house is luxury or not, if you are building a classic models, so there are the lot of feature you will work where you have a categorical data. So you need to convert the data into a numerical format. So I begin with the methods to converting the categorical data into a numerical format or numerical representation. So first is a one hot encoding. One hot encoding, it convert the each category into a binary vector where category present we assign the 1, otherwise we assign the 0, rest of the values. One hot encoding is used only for nominal data where there is no inherent order. For example, if I talk about colors, red, green, blue, black, there is no inherent order. So we cannot give the red is 1, green is 2. If you give this number, so what algorithm will assume? Uh, First I write, for example, if I talk about colors, if I give red, green, and blue, okay. If I assign a random number like 1, 2, 3, if you feed this data after converting the categorical to numerical format, so what algorithm will assume? Red is less than green, green is less than blue. But in reality, there is no inherent order. So we cannot converting the categorical data into a numerical format like that. We need to think because it is a nominal data, means there is no inherent order. If it is order, or it is order. Like if I talk about the educational level, we have a PhD degree that is higher than the master degree. So we can assign the number. Okay. So if you have a nominal data, so you should go for a one hot encoding method to converting your categorical data into a numerical format. And it is used when few unique category. Okay. Suppose you have a three category, so you can use it. If you have a many categories, suppose in a feature you have a 20 to 30 categories, so you cannot do it because it will increasing the dimension of that feature. I will explain. First, I will take example. Yeah, how to convert the categorical data into a number. So let's see first. So you have a color. This is a feature in the data set. Their training example, and these are red, blue, green. We need to convert this categorical data into a numerical format or numerical representation. So how do we do it? I am I am discussing the first method, that is one hot encoding. which is suitable for the nominal data where there is no inherent order. So, first I write, first I convert. So this one is converted. This row, this column is converted into a three columns that I shown here. First I write a red, blue, and green. Then I saw red is red. There is a red. Yes. Here I write 0 and 0. As I discussed, I have to write only one where object or item are present, or rest of the item are the 0. Okay. So 1 here 0 and 1 and 0 because blue is present. Green here I add 1 and rest of 0. So it means for a one feature color, I created a three feature red, blue, and green. Red, blue, and green. So I created a three feature from a one feature. So for red, we represent the red with a 1 0 0. Okay. So I represent the red with a 1 0 0 and blue 0 1 0 and green 0 0 1. Okay. So if you have a many categories, I discussed why it is computationally expensive. If you have a lot of unique categories, if you have it around 10 categories, so you will have for one feature, for a one row, you have a 10 dimensional vector. Here for red, you have a 3-dimensional vector, but here blue 3-dimensional vector. If you have a 10 category, so you have a 10-dimensional vector. It will increase your computational cost and increasing the memory usage. That's why one hot encoding is suitable when it has a few unique categories. Okay. If you have a many categories, so what will happen? It will increasing the dimensions, that we say curves or dimensionality, because a number of categories become a large. So one hot encoding is suitable only when data are the nominal format. There is no inherent order, or it is suitable only for few unique categories. Okay. Let's discuss second type of encoding method where we are transforming the categorical data to numerical representation. So what happened in the label encoding? We are trying to assigning a unique integer to each category. If you have a red, we assign a 0, green assign 1 and 3. So we are just assigning the number. So category may be a ordinal or nominal in nature. It is it is generally used when one hot encoding become ineffective or inefficient, where you have a large number of unique categories. So label encoding is used when one hot encoding is become ineffective due to the large number of unique categories. For example, you have a red, green, blue here. So we can do it. We can do this. If I discuss about the next method, that is ordinal encoding, where it is a variation of label encoding where we keep the order in mind when we assign the number to a categories. So categories have a natural order. For example, PhD, masters, bachelor, higher schools. As we know, PhD degree is higher than the master degree. Master degree is higher than the bachelor degree. So we assign the number in that order: 0 1 2 3. 0 1 2 3. You are able to see it. So label encoding and order encoding. The key difference is that in label encoding we are not assuming any order, but in ordinal encoding we are trying to assuming the natural order, that we leverage that order to assigning the numbers. Next one is a target encoding, is the last method to converting your categorical into a numerical representation. So what happened in this? We are replacing each category with a mean of target variable. We have a category, we are trying to replacing with the mean of target variable. Categorical feature has many unique values. It means if you have a feature, categorical feature, and having a many unique values, you have a 10 20 unique categories. If you use a one hot encoding, it become a difficult. It increases your computational cost as well as increasing the memory usage. So, so how to handle this problem? So we will use a target encoding. The term I use, high cardinality category feature, it means you have a large number of unique categories. So what we do, we register each category with the mean of the target variable. Oh, I explain it with example. Let's take example this. Okay. So what we do, we have a, let's take this example. This example is not for, let's take, suppose here, for example, you have a lot size. Going to predict the lot size, means house size. So 8,000, 10,000, and you have a this categories. I am taking only this category: ranch, colonial, Victorian, ranch, colonial. So you have a ranch one category, colonial second category, and third is Victorian category. There are three category are there. So I have to replace this category with the number. So how I will I do it? For that, I will see first ranch. Okay, this is a feature. This is a label. Lot size is a label. Okay, so what I do, I take a range, this range and this range. These are the values 8,000 and 5,000. What will I do? I will take a mean of that number. After taking a mean, then I place this mean here, range, where range is present. Okay. Similarly, I will do for each category level. But this method, if you have not handled it properly, it will lead to a overfitting. If you have you must do this target encoding before train split, before splitting your data set into a training and validation and test split. If you do after that, what will happen? It will lead to a problem of overfitting. So you need to keep in mind while you are using a target encoding. So you are replacing the each category with the mean of the target variable. Okay. So let us take a example, try to understand four methods what I discussed. So I discussed about the one hot encoding. It is used for the nominal when there is no inherent order in your category, and it should be used when there is a unique few categories. Second, a label encoding. It assigns the random number, arbitrary number to a label, and ordinal category or ordinal encoding, where we are trying to giving a assigning a number when to a category where there is a inherent order like PhD, master, inherent order, and target encoding, we are trying to replacing the category label with the mean of that number. Okay, let's see this method in action. So we have a data set: neighborhood, condition, house style, lot size, and luxury. So in neighborhood, we have a this neighborhood condition, house style, lot size, features, or luxury is a label or target variable. So we have a neighborhood. This is the downtown suburb, downtown rural suburb. So this is the categories, condition is the categories, house style categories, and lot size. This is a numerical, so we don't need to change this. It is already in a numerical format, but we need to handle this categories. So how do we do it? So for that, we know a downtown suburb, it here one category, so second category, and rural is a third category. So in this three category, there is no inherent order. So we can use the one hot encoding, and it is a few unique categories. So we can use the one hot encoding. So I write here. So here you will see downtown one and rest of zero. You will see first entry downtown. Suburb, we here you will see one. Downtown we will here is a one, and similarly for other data. Okay, but here in condition you have a good, fair, excellent, and poor. Here four category, but here we can assign a unique number. uh, Poor is a first, second is a fair, and third is good, and fourth the excellent. There is inherent order in the categories, so we use the ordinal encoding here. So I assign number 3, 2, 3, 2, 4, and 1. Okay, so in a house style, we have range, colonial, Victorian. There are three categories, but there is no inherent order. So we can apply the one hot encoding. So I apply the one hot encoding here. You can see it. Okay, for range 1, a raster value is 0 for range. If I take a Victorian, so you will see the 1, third sample, 1, Victorian and 0. Okay. So this feature, we encode them into a number through a different type of encoding method, and load side is already number, so we don't need to be change it, and we have a target variable in a categorical variable. So how we can handle it? So what we do, yes or no. So there is no inherent order, so we can assign the any number label, as well as we go for the one hot encoding method. So we can assign the one hot encoding as well as number as well, because but more highly recommended that you should use the one hot encoding. What we do here, we will write a yes is a, if I write yes and no, yes means 1 and 0. Here 0 1, you will do it. So so I hope you understand this lecture or concepts of how to handle the categorical data and converting them into the numerical representation that are the required for a machine learning algorithm to learning the pattern which are present in the data set and which can be used for our task. So we understand the four different types of encoding method to converting your categorical data into a numerical representation. First is one hot encoding, second is a target encoding, third is a label encoding, and fourth is a ordinal encoding. So try to make a notes, then it is easier for you to recall and understand in better way. Thank you so much. If you have any query, and if you have not understood any concept, please leave them in comment section. I'm happy to resolve them. So thank you so much everyone. See you in next lecture.